Welcome back. My name is Chris Bianco with the IBM Worldwide Technical Sales team, and as part of this Jumpstart series introducing the IBM Cloudant platform, we'll be delving into a variety of topics that range from how does a NoSQL store differentiate from others in the marketplace, be that relational databases, analytical warehouses, or other NoSQL offerings. How does Cloudant as a managed service stand heads and shoulders apart from other competitors in the marketplace? Where to make the best fit recommendations around a NoSQL store when you have to account for weakened consistency but greater availability and easier scalability. And finally, how do you position and sell Cloudant relative to other offerings in the IBM portfolio? IBM Cloudant, first and foremost, is a fully managed NoSQL database as a service that deploys on cloud as both a public and private managed service, as well as on premises for those customers requiring the Cloudant data layer within the four walls of their business. Cloudant has a variety of consumption models that include dedicated nodes and clusters that are isolated and single tenant to avoid things like noisy neighbors and to comply with data segregation, security, and privacy, as well as for customers who want to consume this in a more agile manner. We offer on the cloud a consumption model built around throughput so that customers can scale and scope their applications built on Cloudant around how many reads, writes, and interactions with the database they anticipate on an hourly basis. IBM Cloudant as a NoSQL database prioritizes availability of their service, making sure that access calls to the database are not subject to locking or to wait queues, as well as easy scalability in that the architecture underlying Cloudant is a masterless or a master-master architecture, which has no single point of failure and can be easily distributed across multiple data centers and even replicated into mobile devices that are running Cloudant-powered applications. They also have a number of touch points from an API perspective. Cloudant can be addressed over a RESTful API that interacts cleanly with the vast majority of programming languages, scripting languages, and devices in the marketplace today, but is also easily addressable through a variety of purpose-built out-of-the-box connectors to technology sets like Apache Spark or even an analytical warehouse such as DashDB. These connectors, for example, allow our customers to easily migrate data coming out of the systems of engagement, be that a mobile application, a web service, or an IoT device, and push that with no DBA oversight and no complex ETL into a relational analytical warehouse where they can go much deeper into deriving insights from that data, performing analytics and statistical analyses of data coming out of those engagement models, and make that available for reporting and analytics in a way that is simply not possible with any distribution of NoSQL database in the marketplace today. Cloudant is unique in having this connector between the system of engagement and systems of insight, and it is one of the key differentiators that draws people towards our platform relative to others in the marketplace. For customers wanting to leverage Cloudant data and indexes from their Apache Spark notebooks, they can take advantage of the open source connector available on GitHub, as well as packaged within the IBM Cloudant stack that allows a customer to query inside of their notebooks indexes that have been pre-built and pre-generated on the IBM Cloudant data platform. Together, these connectors provide immense value to customers that want to extend their application framework beyond simply providing a mobile platform, but also inclusive of data analytics or data science. IBM Cloudant is governed by an SLA, and a unique differentiator new to the IBM Cloudant stack is our reserved throughput consumption model, which is now available on IBM Bluemix. For customers who want a guaranteed level of reads, writes, queries, and data storage associated with their Cloudant account, they can sign up on the fly on an hourly basis through Bluemix Public to this reserved throughput consumption plan. In addition to these connectors and integrations, Cloudant also boasts best-of-breed indexing and search capabilities on every distribution of the platform, be that the managed cloud service or Cloudant running locally on premises. These include full-text search powered by Apache Lucene, secondary views or indexes that are built around incremental MapReduce, and powerful geospatial queries that include data types like GeoJSON, which has become the de facto data type for powerful geospatial tools like Esri or other leaders in the marketplace. And finally, for those customers who want patterns of access built around declarative style queries as opposed to RESTful API calls, Cloudant also offers a Cloudant query data layer that allows a customer in a declarative fashion to access their data in a way that's comfortable to them. Cloudant's platform, from a security and compliance perspective, is amongst the most mature and robust in the NoSQL marketplace today. Cloudant, for example, is HIPAA ready on our cloud managed service, as well as compliant with a number of certifications and standards that apply both to small business and the enterprise. In terms of how customers can consume and deploy the Cloudant service, there are three paths to consider. First is the Bluemix public path, which includes the reserved throughput plan, allowing a customer to be very adaptive and reactive to changing requirements on their data layer, allowing them to scale up or scale back both their consumption and their payments towards the service as their data layer dictates. For customers wanting an isolated single-tenant environment still managed for them as a service by IBM, they can also consume the IBM Cloudant Enterprise path, which deploys both on IBM software as well as Amazon AWS. And finally, for customers that can't move to the cloud or have governance and compliance issues that keep them running on premises, we also support Cloudant Local, which deploys into a customer's private infrastructure running on-prem and is managed by the client themselves. One of the essential use cases that drives many customers towards the Cloudant data layer is our deep integration with mobile application development. For customers that are building a mobile application that might be sometimes offline or occasionally out of connection with a network or Wi-Fi, having the ability to remain productive, still gain access and use out of your application running locally on a phone or a tablet has immense value to those customers and to those looking to build around that use case. Cloudant is the only database within the NoSQL marketplace today that offers offline access patterns so that a customer running a Cloudant-powered application on their phone can continue to do local reads and writes. When connectivity is restored to that mobile device or to that application, the Cloudant-powered application will then write and synchronize changes that you made locally in that offline scenario to the Cloudant cluster running up in the cloud, and vice versa, so that as data points that were changing in the cloud during your period of disconnectivity, those changes are replicated, if relevant, down to your phone and to your mobile device to make sure that locally you're also capturing what's relevant to you as a customer or to a user of that application. This offline first pattern development offers immense capabilities and opportunities to customers that are working under offline conditions. For example, a disconnected car can actively log information and interactions happening with the vehicle under those offline scenarios. A workforce that's mobile and sometimes disconnected from a cellular network can remain productive locally on their device or their tablet powered by Cloudant. And for an IoT sensor that actively logs information under offline scenarios, that information can then be synchronized to a Cloudant data layer where it can be further analyzed and pushed down the line into an analytical warehouse or transformed in a technology store like Apache Spark. A second essential driver of customers towards IBM Cloudant is around our best-of-breed geospatial and search capabilities. These are military-grade capabilities that include things like complex polygonal shapes, the ability to include and exclude data around topology, and other features that are built out of the box to make it very easy for a developer to get started with geospatial and go far beyond things like simple bounding boxes. The crux of the issue around eventually consistent systems boils down to two essential questions. First is the question as to how long can I afford for my data to be inconsistent for? And secondly, what is the cost or the price of that data being inconsistent? For many application developers, they would like to prioritize above all else availability and ease of scale in service to an application framework or a set of customers that may be globally distributed, and therefore time to delivery and responsiveness of the application is absolutely critical. For a relational database programmer, the result may be completely opposite. They may require hard inconsistency and ACID transactions above all else. For these reasons, the debate between selecting a NoSQL or a SQL-based store often boils down to what is the workload in the application structure that you have to support. If it's one that requires hard inconsistency and ACID transactions, a relational database would be best suited for that type of data layer. However, if you're building a mobile application or anything that requires some degree of responsiveness and ease of scale, a NoSQL data store is a much better fit for those types of workloads. That summarizes the 10,000-foot view of the IBM Cloudant data stack. There's a number of opportunities and best fit scenarios that are much further detailed in the provided material that will go along with this video. I encourage you to delve into the resources that are available, as well as the best practice architectures, success stories, and use cases that we built around the IBM Cloudant data layer to help you in your discussions with clients and to help broaden the opportunity for NoSQL stores within a full data stack. I thank you for taking the time to watch today's video, and I'll catch you next time.